Dear students, today we study about the practical of foundation in automobile technology. So the first experiment is we study about the 4-stroke and 2-stroke petrol and diesel engines. So here you can see the apparatus for this practical. So here just the small introduction for the combustion engine. So you can refer this from your left sheet. So first we start to study about the 4-stroke petrol engines. There are 4-stroke petrol engines. Suction stroke, compression stroke, and power stroke and exhaust stroke. So these I explained these 4 strokes through this diagram. So here first we have to study about 2 lines. That means here is one line, that's the final distance of this distance, the maximum distance covered for the distance. And the other thing, that is the distance on the lower value. So distance move between these 2 lines. That means I calculate this from the edge of the piston, this edge and this edge. We call this line TDC. That means top dead center. Here we call this BEC, bottom dead center. So according to this crankshaft, there is a control. The crankshaft rotating like this. So you can see there are 2 full revolutions can achieve this 4-stroke. So first we study about this suction or intake stroke. There are 2 valves in the combustion. This is the combustion cycle first, and there are 2 valves. This is intake and this is exhaust. This is exit. This is spark plug in the center. So first that air fuel mixture inserted through this intake valve. So it's come through like this. So first this piston start to move from this line to this line, this direction, okay, from TDC to BDC. So that time a particular amount of air mixture inserted in the combustion chamber. That process called suction stroke. The second one, that is compression stroke. So after the piston comes to BDC, the piston then begins to start its movement towards the upside until the TDC. So and then the exist air mixture compressed by this piston movement. So here is a particular amount of air that is compressed by this piston. So that process called compression stroke. Here then this ignition plug gives a spark when the piston comes to TDC, not TDC, is near to TDC. That means little before to arrive this TDC line, there is no distance. This spark plug starts to give a spark. So this compressed air reacts with that spark and it obtains the power to this engine. So that time there is a combustion here. So that's pressure give a motion to this piston towards the downward. So again this piston move to this BDC line. So this process called working stroke or power stroke. This stroke is actually linked with this engine power. So again, this piston come to this BDC line, then this again start to move the upwards. That time, the useless air or the burn air mixture exits through this exhaust valve. So that process we normally call the exhaust stroke. Here we can see the related PV diagram for this four-stroke petrol engine. Actually, this is the theoretical diagram. Practically, we cannot get the diagram like this. So we only study about this diagram as practical. Sorry, this is theoretical. From 5 to 1, this area which we can see that is a suction stroke. So this time there is no pressure changes. This is a constant pressure. That time there is a gradual volume increase. So when that means when cylinder there is this intake is exhaust. The air mixture comes into the combustion chamber. So the air volume in the combustion chamber is increased. So there is a gradual volume increase, but there is no any pressure compression process. So the pressure is constant. Then from 1 to 2, this process is compression. So this time the piston is compressed the air towards upwards. So there is a volume decrease. At the same time, because the pressure will increase because of this compression. The next area, just 2 to 3, is totally linked with the ignition process. There is a moment, it will occur the moment when the piston comes to before TDC, little before TDC, the ignition will spark. So that time there is no movement in the piston, so the volume of the air mixture is not changed. At the same time, there is a huge pressure increase because of this ignition. From 3 to 4, this is linked with the power stroke. So when power after ignition the piston move to downwards. So normally the volume of air increase because the piston move downwards. But also there is any compression in that. So the pressure is also decreased. We can see a small area here, 4 to 1. This is from 4 to 5 linked with the exhaust process. So that time the piston move from BDC to TDC. So at that moment this exhaust valve open. So when this exhaust valve open, suddenly the combustion chamber get the pressure drop because there is a way to exit the air mixture. So this compressed air mixture exits through this exhaust valve. That's a sudden movement. We can get the pressure drop here. Then this piston move to upwards. So that time the air volume also decrease. That air move through this exhaust valve. So the volume of this air mixture gradually decrease, but there is no any pressure drop because when this compression, this valve is also open, so that air move through this valve, so there is no any pressure compression or increase. Next we study about the cost of diesel engine. This is also same as the petrol engine, but there is a small difference. There is an injector instead of the spark plug. So the processes are same, but when this piston comes to before TDC, the injector supply a fine amount of fuel. The difference is in the petrol engine, before this compression chamber, the air and the fuel mix together and come to this engine like a air fuel mixture. But here there is no fuel mixture here, only come to pure air, and this air compressed by this piston, then the fuel supply before this working stop. But there is a small difference because that petrol engines, this compression is normally less than this diesel engines. For an example, here there is a high compression than the petrol engines. Otherwise, we need an ignition, spark ignition to burn to this air mixture. So this diesel engines are highly compressed than the petrol engines. The next page we can study clearly about this. So for an example, I can show you. This is called compression ratio. That means this is the TDC line. Okay. This is the TDC line. So the total volume of this is 10. Here after TDC, the piston cannot move. There is a small area gap. Okay. So this compression ratio is this total value is to this remain place. That means that's one. So then air mixture is filled with this whole area, then it's compressed to this 1%. That means total area is have 10 and this compressed to 1. So the 10 into 1, the compression, which normally the petrol engines the compression ratio is between the 10:1 to 14:1. Okay, but the diesel engine is normally called to is actually 25:1. So that compression ratio is 5. That means, for an example, here is 25 instead of 10. Here 1. So this ratio is very high. That means that 1 is here. Compare with this 25 ratio. So because there is no spark ignition in the diesel engine, so that spark or that burn mixture is achieved by this high pressure compressor. So here we can show that the exhaust process also same as the petrol engine. So this is the PV diagram for diesel engines. Here the same as the engine. You can see one thing. The 1 to 2 is a compression stroke, but the petrol engines normally achieve the high pressure to this area like this. That is compression, and the ignition process, the pressure achieved to this point. But here there is no spark ignition, so that high, because of this high compression, this particular amount of pressure achieved by only this compression process. Okay. And here there is an injection process. That time the volume is rapidly increased, but there is no change in the pressure. Then from 3 to 4 there is a power stroke. It is also same as the petrol engine. Okay, I already explained that. It's both are same, and this process also same. When the exhaust valve is open, there is a sudden pressure drop, and this when the burn air mixture exit, there is a gradual volume decrease. Then we study about a two-stroke petrol engine. I think we can study this along with this animation. That's very easy to understand. So here defined is there is a spark plug but no intake or exhaust valve in the upside. There is no valve actually, it's a manifold. There is no valve or there is no block close, open or close. This always open. This is the exhaust valve, this is the intake manifold, this is the crank case, and this is the crankshaft. This is connected with the piston. So what is the working animation? So the piston moves upside, because here you can see the difference. In the 4-stroke engine, the piston starts to move from TDC to BDC, from upside to downside. But here, the piston starts to move from this bottom BDC. So, what is 2-stroke? In the 4-stroke engine, there is when the 4-stroke complete, the 4-stroke complete, when the crankshaft rotates the 2 revolutions. That means there is a crankshaft. When the crankshaft here is a intake suction, and this the crankshaft rotates with the 180 degree. That is compression. Then that's a 180 degree. That is then we start to power, and this area again that's another 180 degree. That is exhaust. So there are 2 revolutions. But here that's 2-stroke. So only the 2-stroke finish. Only the crankshaft rotates at 1 revolution. That means here that's intake, the piston move upside. So here the ignition is spark, then that's the power stroke. At the same time, the exhaust valve, the burn air also exit. So 2 processes. The first half there is an intake, ignition, that's power, compression. Intake, compression, and here power and exhaust. So we can see from this piston move upside. So the air comes through like this. Okay. So this air comes to chamber and this compress. When it comes to before TDC, the ignition plug spark. Okay. Then wait. I will display the animation. So this piston go to this way, then air come to this crankshaft and it come to here. So here is the ignition spark given. So here that's ignition start, then down, here's the downside. We can see there's a power source, this piston up to downside. So this burn air mixture exit through this exhaust manifold. So this is a two stroke. So there are two stroke combined between one stroke in this engine type of engine. So what is the advantage and difficulties of this engine? First, this type of engine is very powerful than four-stroke engine, because when the four-stroke engine and two-stroke, when the four-stroke engine get power stored, this two-stroke engine get 2 times power, because this is a two-stroke. So that means when, for example, when four-stroke got 10 times power stored in a particular time, that if this two-stroke engine is a double, it's a 2 times, double times it gets that power. So normally this power is double times than a four-stroke engine. But the problem is we cannot expect the high economy, fuel economy, because there is no intake to outboard valve. This is always open. So there is no more restriction or any other control of fuel. So this type of engines have less fuel economy. So we can study about, for example, the single cylinder engine. Okay, it will get power there's a four quarter. Here's the grand rotations. So it gets the power flow in this half, this quarter. Then it gets the power after 3/4. That means there's a gap, time gap, because it's only one piston. So it gives the power to the power to third stroke. Third is power, okay? Compressor power. Then it gets the power. Then fourth is exhaust. Then again start the first suction, compression. Then it gets the power to fifth, sixth, seventh. Okay? So there is a time gap. So because of that, in the manufacturer, vehicle manufacturer, it is for multi-cylinder. For example, four-stroke. So there is a 4-cylinder like this. 4 piston, 4 cylinder. So when this piston finish the power stroke, we don't need to wait for the another power stroke because the other cylinder start the power stroke. So this engine is temporarily got the power stroke. So for the smooth operation. So this type of engines are very smooth than the single cylinder. That's why this manufacturer introduced the multi-cylinder. So that means there is a four stroke. Okay. So this the four stroke engine we can continuously get the power stroke. Okay. First, second, third, fourth. First, this is okay. This is one cylinder, this is second, this is third, this is fourth. First, suction, compression, power, exhaust. So, the next one from example. You can get the emission or something, for example, suction, compression, or power. Everything can have that. Everything can have its order. For example, this is power. This is exhaust. This is suction. This is compression. This is compression, power, exhaust, suction. So we can see the first time where the first third cylinder get the power, the second cycle the fourth cylinder get. So the continuously it get the power stroke. But the sixth cylinder, what happened? The sixth cylinder there is a fifth, sixth, but there is a fourth stroke in the engine. So that means that is overlap. Overlap means when this first the third piston finish the power, then the second, the fourth cylinder start its power. But the sixth cylinder, this power finish, the another cylinder obtain the power. Okay? There is no time there. When it finished, this power stroke is start for fourth cylinder. Okay? Then the other cylinder is start. But in the sixth, cylinder engines, the one of the cylinders finish the power stroke, but the other cylinder start before it finish. So there is an overlap. This area that both cylinders are working the same time. This cylinder, the two cylinders working same time with the power stroke. So these type of engines are very small, which used mostly for sports or expensive cars. So there is another problem. You can think these pistons are connected with the crankshaft. So if there is a 6 cylinder or 8 cylinder, we need a length crankshaft. But the difficulty is sometimes this length crankshaft may twist or broken because of the high length, and we need the very big bonnet of the car. I mean that's bonnet. This bonnet we need very big because of this high length crankshaft. So avoid this difficulty, they found the V-type cylinder. That means this is a normal cylinder. This is a V-type. Here, in the one crankshaft, there are two pistons connected, like the V-shape. So, these two pistons are connected in one crankshaft. These two are the one. These two are one. These two are one. Okay. So that means this is another cylinder. This is a second, third, fourth, fifth, sixth, seventh, eighth. That's a 8 cylinder. That's means V8 engine. Okay. So this type of arrangement reduces the crankshaft length. So the other benefit of this system, you can see this type of arrangement, the piston is moved up and down only. So the total system transfers vibration the up and down. So here this type of piston, some other pistons are in there, that's a rotary engine. That rotary engine means that there are several pistons connected is 360 degree. This is rotating. So the all forces are balanced by this piston. That V-cylinder also, the forces are not opposed any forces. Okay, the both forces are working like this. So the vibration of this total arrangement systems, vibration is considerably reduced. So these type of engines are very smooth. So then we study about the back of the engine. So first study about the firing order. Firing order means there are 4 cylinders in the engine. So that's the start of okay. Cylinder is 1, 2, 3, 4. So there's a firing order. That means the normally that 4-stroke firing order is 1, 3, 4. That means first this part is start to fire. Then the third cylinder is fire. So then the 4th cylinder, then finally the that means we can get the power strokes order 1, 3, 4, 2. This is the order. So 8 stroke. That means when it gets the ignition, the third cylinder will be in the previous stroke. That means the compression stroke. So because after this ignition is achieved, the ignition occurs in the third cylinder. So this is the process. So we can see, for an example, this is in the 4th process, exhaust. So that time, the same time, the third cylinder is in the 3rd process. That means power. The 4th cylinder in the 2nd process. This is the 1st process. So this continuously, this type of process continuously occurs. So it finishes, then second this and this. fourth cylinder, and this is finally the second cylinder. So the firing order means that's the initial order, but we can determine the whole process, suction or power, all that come under this order. So that is the firing order provided on the cylinder engine. And the other thing, that is the valve clearance for the provided engine. So I will tell the valve clearance. So the valve clearance means, so you know now the firing order. Okay, 1, 2, 3, 4. But I 1, 2, 3, 4. So first firing order is, I write here. This is first actually. This is second firing order. So according to this, the valves are into open. First, this is the intake stop. The intake valve into open. This is exhaust. This exhaust valve into open. So that time, some of other valves are closed. Okay. This depends on the stroke. When this is intake stop, we cannot know because we know the firing order. 1, 2, 3. That is the firing order. This is the second one. Okay. So we can understand when these valves are open. This is the intake stop. So where is the other? There is many other valves are open or not? We can find because we know the firing order. So there is a two method. We can find the valve clearance settings. Okay. There are two valves. Okay. This is the piston cylinder order. Here valve number 1, 2, 3, 4. This is intake. This is exhaust. This is intake. This is exhaust. Here. Okay. Here my number. Here total 8 valves. So here are the two views. First, we can see in the crank. You know the crank. I saw in the practical apparatus. No, I understand this type of crank. There is a mark here, yellow or something. And there is an engine case. The engine case also has a mark. When these two points are missed, okay, when rotate the cranks are by holding the cranks or any other towards that time, that is towards engine timing. That time, the first cylinder piston, this time the first cylinder piston is in the TDC. Okay. So when this crank wheel is in the timing mark, this piston is in the TDC. That is first cylinder. So what happens that time? This is near to TDC. So that time, this suction stroke also going to start, but the previous stroke is exhaust. That time exhaust also come to end. So that means this moment, this intake suction intake valve going to open. Okay. This exhaust valve going to close. That moment, these both two valves are open. Okay. Then, so that time we can identify. So we can find. This is a first stop. So we can know then the third cylinder come to the intake suction stroke to next flow. So we can find. So this is the intake procedure. Then this is come to exhaust. The previous procedure of this process. Okay. So there are two methods to do valve clearance. First method is called companion cylinder method. So we know when this timing point here, the timing point here, that time this first cylinder, that means 1, 2. When 1, 2 valves, the first cylinder of 1, 2 valves are open. So there is a single method here. We know 1, 3, 4 is a firing order. So we write here, we write 4 like this. 1, 3 like this. Okay. 1, 3, 4. 4 to 1. That means this first cylinder, 2 valves are fully open. That time we have to adjust the fourth valve, the 2 valves. So when the third cylinder, both valves are open, we can adjust the second cylinder, both valves. So that's the same. One is cylinder is open, the both valve, we can adjust the fourth cylinder. The fourth cylinder valves are open, we can adjust the first cylinder. Second cylinder valves are open, we can adjust the third cylinder. This is the companion method. The other method is, that's also same as this. That means rule of 9 method. Rule of 9 method. That means we need to adjust the 6 cylinder. The valve I also is a valve number 4, 5, 6, 7, 4 and 8 cylinder. First, second, third, fourth. So we need to adjust the 6 valve. This means the valve of exhaust valve of third cylinder. So the total must be 9. So how do we do? We addition the third number. So that means when the 6 cylinder is open, 6 valve is open, we can adjust the third valve. Okay. When this third valve is open, we can adjust the 6th valve. They are interconnected. Okay. These 2 valves are interconnected. The total of this 4, 5 is 9. That's why I already told the companion cylinder also like this. This second cylinder, both valves are open. We can adjust the third cylinder. Both are interconnected. Two companion cylinder rule and rule of 9 method. So this is a little bit complex. I can really explain when I am doing the practical. So there is a find the intake and exhaust valve timing diagram. Here so we can for example here, that means we know the first cylinder both valves are open. That means this is TDC. That near to TDC normally, that exhaust valve is open. Start open here. Okay. The exhaust valve start here. This crank rotation, and this when is complete. This is TDC line. Little bit after the TDC. So that intake valve open little bit before the TDC. That means there are some 360 degree. The exhaust valve close after 5 degree TDC, and this intake valve open before 10 degree interface. That's why that time the both valves are open in the same time. There are few some amount of time. So this time area, this black area, that both valves, exhaust and intake valves are open when this area. So this area called valve overlap. That's valve overlap means the both valves are open at the same time in a few amount of time. So this is the valve lining diagram for four-stroke engine. And I have already told about the compression ratio of the calculation, and there is a discussion that's for your consideration. Thus, you need to work with these discussions. Then the final thing I need to show. There are two types of valves. Okay. Here, this is a crankshaft. Okay. This is a camshaft. So we have crankshaft. There is a rope. There is a rope shaft. This is called rope shaft. This rope shaft are connected to this camshaft rope. According to the cam rotation, this move back and downwards. So it's control the valves. When it's moved the downwards, according to that, the valves also move up and downwards. So when you get the gap, the fuel over there is enter and exit. So here we can adjust the valve to this area. I will clearly show in the apparatus. So this is the rocker end arm valve. This type of valve, the valves are not directly connected with this camshaft. There is a rocker end. These type of camshaft are in the upside. Okay. So this type of camshaft, the valves are directly connected with the cam lobe. There is no any other rocker end. Okay. But here we can see there are two camshafts. That means this two valves for intake and these two valves for exhaust. In each cylinder have two valves because this type of engine are more efficient because lots of amount of air can intake, air mixture can intake and exit because of these two valves. So this is the another type of the engine. So I think this is the end of this lab sheet. And I continue this experiment with the apparatus. Right. Okay, students, let's go with the practical apparatus. This is the cut model of the engine, and here you can see the 4 piston petrol engines. So there is a 2 valves. Each cylinder have 2 valves. This blue color is intake and this is exhaust valve. This is a valve spring and there is a spark plug here. Okay, so this is the crank wheel, and this side this is the cam shaft is connect with the chain, and here this is the shaft of the cam, and you can see here this is the rocket arm that is connect with the valves. This is the rocket arm. There is a cam block that is connect with the valve of the other side. There is a spring, and when valve adjustment you can see there is a nut. Okay, you have to loose this nut and you have to adjust this, that means this nipple you have to adjust, and this is the feeler gauge. This feeler gauge has this feeler have in inches, so there are a lot of inches, not 0.05 inches, 0.1, 0.15. Every feeler gauge has its mark in the inches. So specifically that automotive manufacturers normally give the valve clearance. That is not a standard value. It's depend on the automotive industries. So when they release a model, they also determine the valve clearance for their manufacturer. So here in the intake valve and exhaust valve, normally the intake valve clearance is less than the exhaust. That means exhaust valve clearance is little bit higher than the inlet valve clearance. Here when we lose this nut, we have to check the valve clearance. For an example, here I take the 0.25 inches. When I lose this nut, I have to check the valve clearance. Okay, I tell clearly. See, this is the piston number 1, number 2, number 3. This is number 4. So the valves also. This is for number 1, 2. This is for number 1 piston valve, 2, 3, 4. For an example, this is number 4 piston valve. This is intake and this is exhaust. So then the firing order of the engine we can see in the engine body here, that is 1, 3, 4, 2. That means this is the first cylinder, and 3 the firing order also 1, 3, 4, 2. Okay, I already told in the theory part. And here you can see that the crankshaft, I already told about the timing mark. There is a yellow mark here. This yellow mark mixed with this mark. Okay, this is the mark in the wheel, this is in the engine body. The both are mixed. That means that's the same direction. Okay, so that time I already told this timing mark, the cylinder of the piston of the cylinder, first cylinder, piston of the cylinder is start to work its suction stop. That means it's this little bit before in the TDC line. So that time the both valves, the intake and exhaust valve both are open. Okay, so according to the companion cylinder law, I told when that first cylinder 2 valves are open, we have to IS the 4-cylinder 2 valve. So this time you know this is in the timing mark, so this both 2 valves are open in the first cylinder, so that time we can adjust the 4-cylinder 2 valves. Okay, because these 2 valves are normally closed now, this is normally open, so that time we can adjust the valve clearance this closed valve. So directly this first cylinder is connect with this 4th cylinder. So now you can see how we can adjust. So first I need to loose this nut. Okay, now this nut is loose, and then so this is a intake valve. So normally I take them 0.25 inches 0.25 inches feeler gauge. So first I have to loose this nipple. Now there is a plate, the gap. So you insert this feeler gauge. Now the gap is too high, so you have to adjust. Now it slightly touch the feeler gauge. Okay, the gap is slightly touch the feeler gauge. So this is a 0.25 inches. Now the gap is clearance is correct, so I tight the nut again. Okay, so now the time for the exhaust valve. So the same procedure I am doing here. So it's loose. So nut was loosened. Then I loosed the nut was loosened. So then I loose the nipples also. So we can get the plate. Here I already told, here we fix this. Okay, here we fixed a 0.25 inches. I already told the exhaust valve is higher than the intake valve clearance. So I select here 0.3 inches. So there is some more cap. So I adjust. Yes, here the cap is high, so I rotate the screw. Again I need to. So now is slightly touched. So this is now this clearance is 0.3 inches. So now I need to tighten this nut. Okay, so this is when the first cylinder, these two valves are open, we tighten this fourth cylinder. So when the fourth cylinder two valves are open, we can tighten the first cylinder. Both are interconnected with this system. And so now, so this is the crankshaft timing point. Oh, I already saw there is a post off. So now we rotate this mark to by the 180 degrees. So this mark is now is come to this 180 degrees. That means this is the suction stroke for the first cylinder. So the firing, according to the firing order, the next cylinder of the after first cylinder is 3. So then when this mark is going to here by 180 degrees, the third cylinder come to this actual position, the suction position, because the third cylinder is next to the first cylinder. That's the firing order. So when we rotate this crankshaft by 180 degree, that we can get the third cylinder fully open. So that time we can adjust the second cylinder because of this companion tool. I already know 1 and 4 is connected and 2, 3 are connected. So when that both valves are open in the third cylinder, we can adjust the second cylinder. Okay, now we are rotating. You can see. Focus the piston. The piston also moving, and you can see the third cylinder that's going to this TDC. Okay. Now you can see here there is a case, that's why you didn't see the gap. Actually this time this both valves are open. That means the exhaust valve is need to close in some few amount of time. That intake valve also open. That means that called the valve overlap. In a time that both valves are open, that called the valve overlap. So you can see we can get this mark in a 180 degree. So now the third cylinder is in a suction stroke. That's like the first cylinder. So now this is going to suction. So we can these valves are fully open. So we can adjust the numbers 2 cylinder valves. Then the firing order is, then we can rotate. So now firing order is four cylinder. So it's come to TDC line. Now you can see, okay, there's a gap. You can see the both valves are open. There's a gap here. So this time, this TDC line now the fourth, there's a both valves are open. That's a valve overlap time. So we can see also the crankshaft. So we can complete the 360 direction. So this is come again to the timing mark. That means before we got this timing bar in the first cylinder position. Now we got the fourth cylinder. That's why I already tell the first cylinder and fourth cylinder are the same position in every 360 degrees. Then that's also the second and third cylinders also the same, but because that's also same as every 360 degrees. So according to that, now the fourth cylinder both valves are open, so we can adjust the first cylinder valves. So the same procedure we already did, so I didn't explain anything. We can follow that procedure in each valve, and we can complete the all valves. So we need the 2 revolution, crankshaft revolution, to accomplish this total valve clearance. I think this video will useful for this. So I think I complete the all things, the valves and pistons and how it's valve clearance. So this is the end of this practical. Thank you. Stop.